Chapter 9, Exercise Set, Problem 2. In 1995, Cook County, Illinois, which has about 1.4 million households, conducted a study to determine how far the head of households travels to work. A simple random sample of 2,518 households was chosen, and the occupants were interviewed. The survey found that the mean commuting time for the head of household was about 42.6 minutes, and the standard deviation was about 16.7 minutes. Okay, let's begin. Explain why the normal distribution, or z-distribution, is appropriate for the inferential analysis in this case. Why z-curve? The reason is the sample size. Sample size is large, larger than my threshold of 100. By the way, why am I using 100? Let me show you that through the t-table. Okay, here's a t-table. And please take a look at the degree of freedom here. 1, 2, 3, 4, and so on. df is n-1, so this is related to sample size. And up to 30, we have every degree of freedom, and then increases to 40, 50, 60, 80, and then 100. And after that, boom, over to 1,000, and all the way to infinity. What does that mean? Up to 100, this table is reliable and useful, and beyond 100, not very useful. That's what it says. And that's why I'm using 100 as a threshold. Now, if you look up some old textbook, then sometimes you see a little bit lower threshold, like 50, or sometimes even as low as 30. And that's because t-distribution is usually harder for computation, and people wanted to cheat out of t-table and use z-table as much as possible. But then again, that was 50 years ago. Nowadays, computation is not too much of a deal, so the threshold went up. We are using about 100, that's appropriate. And about 30, that's too low, I don't like it. Up to 50, I will tolerate. Anyway, this is z-table problem because 2,518 is way over 100 or any other threshold you can think of. Okay, let's resume. Estimate the 95% confidence interval for the true mean commuting time. Okay, here we go. 95% confidence interval. Let's begin with a picture. Here we go. If you draw a hand-drawn picture, please follow this procedure. 1. Outline, 2. Center, 3. End, and 4. Shade. Outline is like this, kind of bell curve, and unimodal, asymmetric, and so on, and the center is the expected value. Observed mean of 42.6 minutes, that goes right to the center, and the middle portion is related to the confidence level. 95% confidence interval, so we need 95% in the middle, and consequently the other 5% must be shared by the left, 2.5, and then right, another 2.5%. This picture is symmetric, so we can find one end and use symmetry to find out the other. Whether you find out right or left, it doesn't matter to me, but my preference is to find left-hand side. If you prefer to do it with right-hand side, go ahead. I do it to the left. Okay, here's a solution, and we use the formula number 1 here. Z equals n minus center over SC. As you can see from the color coding blue, I'm looking for the left-hand side endpoint here. And x minus the center of 42.6, yeah, okay. X minus 42.6 over SC, standard deviation of 6.7 over square root of n. That is equal to appropriate z-score. And that z-score turns out to be negative 1.96. Why is that? Let's find out from the z-table. Okay, here's a z-table, and then we need to find out 2.5% here in the left. So let's look up 2.5%. Right here, 2.5%. Negative 1.96, isn't it? Negative 1.96. And that's how we got negative 1.96 over here as z-score. So what do you get? X minus 42.6 over 16.7 over square root of n is negative 1.96. Let's solve this equation. Flip the denominator to the other side, then we get z squared of negative 1.96 times standard error. We get that. And flip this center, 42.6, to the other side as well, then we get this computation. 42 minus 6 minus 1.96 times the SE. Punch in the calculator, and you're going to get this value, 41.9477, about 41.95. As you can see from color coding, this is blue, so it's this value over here, x1. How do you find the other endpoint, x2? On your right hand side, just use the symmetry. Change this minus to plus and run your computation, and then this is what you get, 43.2523, and that's what it is. If you try to find this one first, that's okay too, except that you're going to get this one first and then change this plus to minus, and that'll give me the other endpoint. Either way, it works out. It doesn't matter which one you do. I just happen to do it to the left. Finally, here's the conclusion. 95% confidence interval is 41.25, 41.95 to 43.25, excuse me. And here's the picture. Okay, now let's go over to the third problem here. Estimate the 95% upper confidence bound. This one's different, not the confidence interval from where to where, just confidence bound. So you're looking for just only one endpoint, as you can see in this picture. Upper confidence bound, so above the expected value, and this is it. 42.6 is the expected value. Higher than that, we have this end, and 95% is this middle and the left, the blue part, and 5% all go to the right. Compare this with the previous picture. 95% in the middle, so 5% must be shared by left and then right. 2.5% here, 2.5% there. Not this time. 95% here and 5% goes over here. So what do? Let's set up the z-score computation and solve the equation using this x minus 42.6 over SC, and the left-hand side is 95%, so you'll have to look up appropriate number from the z table. Well, here we go. N minus center over SC should be z-score. X minus 42.6 over SC should be appropriate z-score, and I claim this is 1.645. Let's find out. Let's go to the z-table. Just give me a moment, please. Okay, this is a z-table, and this doesn't look like 95%. Yeah, all these are less than 95%. Nothing in the first page. Let's go to the second page. That's bigger than half, so this must be right. In the second page, we can find 95% somewhere, and here we go. 1.64 and 1.65. So the real z-score must be somewhere in the middle. 1.645. That's how I get this estimation. Alright, from this equation, let's find out x. Flip that denominator over to the other side, and then add the center as well, and we'll get this computation. 43.1494 approximately speaking. And here's the conclusion, along with the picture. That's the upper confidence bound, about 43.15. Coming back to computation, here we go. The score computation, that gives you your equation, and solve for x through these two steps.